Okay, going to go over a couple of problems from the 513, 514 worksheet for Hon Trig. All right, the questions that were asked had to do with this section right here. You roll a pair of dice, find each theoretical probability. All right, most of the problems here have to do with the sum of the two dice. So when you're dealing with rolling two dice and you need to find out something about their sum, it's usually in your best interest to make the table that shows all the possibilities. All right. Usually it only takes a couple seconds to generate this. The way that you read the table is that 1 through 6 up here represent the 6 possibilities for one of the two dice. The 1 through 6 represents the other one. And then each one of those boxes inside the main part of the table represent the sums that you could get. So for example, that 9 represents rolling a 3 on this one and a 6 on that one to give us a sum of the 9. Well, in this main part of the table, we have 36 total boxes, and we know that from the fundamental counting principle. If there are 6 ways for the first die to land, 6 ways for the second one to land, then that's a grand total of 6 times 6, or 36 possible outcomes. Alright, so from this section here, the specific questions that were asked were numbers 18 through 20. 18, 19, 20. So for number 18, what's the probability that both are even? Okay, that means that the one die represents an even number, the second die represents an even number. So the possibilities of both dice being even numbers would be rolling a 2-2, a 2-4, a 2-6, a 4-2, a 4-4, a 4-6, 6-2, 6-4, 6-6. So of the 36 possible outcomes, we've identified 9 of them that satisfy this condition of both dice being even. So a 9 out of 36, or a 1 out of 4 chance of that occurring. As a general reminder, when you're answering probability questions, they can be answered as fractions, decimals, or percents. Usually when you're talking about things like rolling dice or choosing marbles or things like that are little nice, clean, compact, prepackaged problems, most of the time you're going to see the answer in fraction form. They can be expressed as decimals, they can be expressed as percents, but that's normally the way you would see it. Okay, next question, number 19, a 1 is rolled. Now, possible point of confusion with this problem is it's not referring to the sum being 1. They're very specific on this worksheet of the sum being 7, the sum being 11, the sum being less than 6. A 1 is rolled refers to one or both of the dice being a number 1. So going back to our table, what I did is I circled all the possibilities that represent a 1 being rolled. So it could be a 1-1, 1-2, 1-3, 1-4, 1-5, 1-6, 2-1, 2-3-1, 4-1, 5-1, 6-1. Count up how many circles fit those conditions, or that condition of a 1 being rolled. There's 11 of them, so there's 11 out of 36 chance that a 1 is rolled. Okay, final one from this group, a 4 or 5 is rolled. Again, it's not referring to the sum being 4 or 5. This worksheet is very specific about when they're referring to the sum. This means that an actual one or both of the dice have a 4 or 5 showing on their faces. So what I did is identified all the times where this occurs. So all of these going across, represent 4s or 5s. All of those going down represent 4s or 5s. Count up how many of those circles we have. 20 of the 36 possibilities represent one or both of the dice being 4s or 5s, and that reduces to 4 out of 9. All right, the other question from this worksheet was number 35, I believe. So the prompt for this says a drawer contains 7 red shirts, 5 blue shirts, and 4 white shirts. 1 shirt at a time is taken at random from the drawer and not replaced. Find the probability. So when we're making successive choices one after the other, one of the important facts we want to identify is the first thing being replaced before the second one gets chosen. Okay. If the first one does get replaced, then what happens is we have independent events. If the first thing doesn't get replaced, which is what happens here, then we have dependent events. What happens on the first pick affects what happens on the second pick. If it's with replacement, then once it goes back, the first pick has no impact on the second pick. All right, the specific question was both of the shirts not being blue. So recopying some of the important stuff here. We have 7 red, 5 blue, 4 white for a grand total of 16 shirts. We're choosing one at a time without replacement, and we're interested in what's the probability of both choices being not blue. Well, of the 16 total shirts, 11 of them were not blue. So with that first choice, we have 11 out of 16 chance that that first shirt is not blue. Now we don't put it back. They said specifically in the problem it's without replacements, or there are 15 shirts left to choose from. Now the first one we picked was already not blue. So that means there are 10 not blue shirts still remaining to choose from. So of the 15 shirts that are in there, 10 of them are not blue. And then our multiplication rule here is we want to multiply those two things together. Doing it by hand, you get a little bit of reduction before you do the multiplication, and we get an 11 out of 24 chance of that occurring.